I'm Mesringer, and today I'm going to talk about the contact process. Basically, this is what I have been working on lately, and this is going to be the weekly report 3. So, what I have been doing this week is to recap everything that I have done. I have been measuring and testing out the thermocouple and how I could automate the system with the Arduino and the relays and the thermocouple. Basically, there is two thermocouples that I have used. This is the Max 6675, and there is another one which is connected to this little multimeter. So this is like a temperature reader. Here it says 9 degrees, so it's called fucking here. To basically test out how efficient and how well the outside thermocouple works and what the specifications are, I have decided to measure the inside temp. Last week probably overheated it, the catalyst, and probably sacrificed a bit, but I have lot left. If I want to, I would just dip it back into the solution and put some more on it, basically, or whatever. I will figure it out. But probably overheated it and sacrificed some vanadium. So that's fine, because I'm just testing it right now. So this is not much is visible from here, but this is the quartz wool that I have, the rock wool. Inside that, there, as you can see, this is the coil, the heating coil, and basically this is like a little shitty insulation, but it quite works well, because when the inside temperature is 460 to 500 temperature, 500 C, it's 76, 79, 80 degrees C outside that the temperature probe, the max 667 or 5 can read. The problem with this setup, or at least now currently, that I have been working on, is that the whole setup, basically this rock wool doesn't have, puts a temperature delay into the system that has to be compensated for, because now basically the metal ring and also the Max's thermocouple needs to be heated up. They are made from steel, and they have some time. They need some time to basically get to temp. If there is a temperature here that's 70 degrees, the steel needs to first heat up, and it takes time because it has significant mass compared to the quartz wool and compared to all those things. So yeah, this needs to warm up, and that takes time. When the temperature hits I don't know, it was working temp, so it's 450 C. Outside it was still reading 25 C. So yeah, that's the the delay I've been talking about. What is really not easy to compensate for is that now this was a static test, in that sense that I have not pushed through the hot gas with the sulfur dioxide in it. Basically, that's going to increase the temperature inside, and also it is going to put another variable inside, because the conversion of sulfur dioxide to trioxide on the catalyst, vanadium pentoxide, is generally exothermic, meaning that it produces more heat than I designed the system for, and I need to test it with the gas. Basically, I would call this the dynamic test, because it introduces the hot steam with the sulfur dioxide in it. And I call it steam because there is water vapor in the air, so that's steam when it is hot. You get the point. So the hot gases will make it exothermically react with the catalyst, and that's going to make more heat, and that's going to be harder to dissipate than in the static environment. Basically, now it cools off faster than if it were run with the sulfur dioxide. What I have been trying is that I have measured the time that it takes to cool off for the static setup. It is you could say that it is kind of useless, But in the future, if I want to like calcinate these other quartz wool pieces or something else, I could use that static environment, because then it is like just that temperature, and it kind of works well. There have been a bit of like tinkering around with the waiting times, but that's okay, because when the temperature gets like too hot, as I said, it's like working temp inside 450 degrees C, when the temperature probe outside still measures 25 C, so that's absolutely bullshit. So there is like too much delay between, so you need to time it and then adjust the time depending on the average temperature. So let's say I have been waiting for 30 seconds, or in my instance 20 seconds, for the temperature readings. Every 1 second is happening basically, and I have been collecting 20 readings, averaging them out, and writing them on the screen. Then the probe, I set like a ideal temperature range, let's say from 68 till like 60 or 68.8 till 69 nice C. And if it is above, the average temp is above at the working conditions, because first you need to get into that mode, but we will talk about that in the other video. When that gets hot enough, then it will like increase the waiting time after the heating, because the period that there is like a two how to say this, two period of it, the two types of period. Then first, that the heating, that the relay, the Arduino turns on the relay for 10 seconds, it heats up the coil, then the temperature goes up basically like 20 degrees C, and it goes up, stagnates, then it goes down. And for the going down, it waits like 27 seconds, but that's completely irrelevant for you, because you would like get the you have a different type of coil, so that's like, and also different type of rock wool, whatever, so you get the point. But for reference, it is good. Waiting, and it is when the working conditions are met, basically the temperature, average temperature is above certain degree, let's say 68 or something like that, then it turns into work mode. Then the off time, that the Arduino waits till the temperature goes back, is increased, so the temp goes basically lower, and the amount of heating that it does is still constant. So as it goes lower, it goes up, it goes lower, and you get the point. It goes up, goes lower, goes up, lower, goes up, lower, goes up, lower, and like this it goes back to the certain threshold. If it is lower than that, then it is going to decrease the time, so it is going to up, increase, you get the point. Yeah, I've been working and tinkering with that, but next week, now you can see the environment here, is that I've glued on some with high temp resistant silicone, this other high temp resistant silicone, whatever, tubing, that the absorbers, these little shitty absorbers, is going to, just for the sake of testing, going to connect to. I'm going to put in this end, whatever, but as you can see, the temperature reader with the multimeter has been put like a hole into that, and it has been led into the quartz wool inside. That is probably not visible from here, but like that's in there. There is the it's not really visible, whatever. So the temperature reader's probe is in there. I'm going to take like real readings, temperature readings from the inside, and I'm going to compare it to this outside temperature readings and see how it changes with the like the dynamic setting, that basically when the sulfur is coming in with hot gases, how it's going to affect these static settings, and I'm going to adjust to those. I will need to wait because this now is curing. I've made this yesterday, so yeah, next week going to get to the testing period, going to test out how it can be like set what's the temperatures, what the waiting times are, all that stuff. I'm going to make the system like quite stable in the sense that it is going to fluctuate around 450 C. So it's going to favor the production of sulfur trioxide in that temperature range. Above that, it's not really great because other byproducts are made, and also conversion back to sulfur dioxide is stronger, whatever. So yeah, lower is going to reduce the yield also, but whatever. And also read about it, you can actually make formaldehydes with this shit, like, or aldehydes, basically formaldehyde and acetaldehyde with it, if you set the temperature to like 300 degrees or something, and you pass methanol or ethanol, yeah, of course, depending on what you need, formaldehyde from ethanol and or no, sorry, so formaldehyde from methanol and acetaldehyde from ethanol is going to be produced, if I'm correct, at the vanadium catalyst. So basically the same setup could be used to make formal or acetaldehyde, which is like upcoming project in the future, if I can like make this happen. I mean, I will make this happen like regardless of the conditions, but like it's going to take more time if it's something like fucks up. Yeah, also, like a little side note here, I have made calcium chloride basically here. So I made some calcium chloride in here. It contains a bit of chromium, so this is why it is like slightly bleached in. But yeah, I made some of it, so I will be able to utilize this in this contact process basically. So here basically I will, in this chamber, I will burn the sulfur. Here is going to be a messenger. I'm going to upgrade the system in the future to better sealing jars or vessels, and also change the tubing to like Vuitton tubing or whatever. But like for now, it is going to be good for the like the raw version, like the Mark 1 prototype. So this mason jar is going to be put here. It's going to contain the calcium chloride to desiccant, basically to dry out the gas, so remove the moisture from the air. With the production, basically the other process, the Oswald process, that is you making ammonia and passing the ammonia through the platina catalyst. That's a bit of hassle, or starts from a worse position, because it is like in a liquid state, basically in a aqueous solution. In the aqueous solution, you can never guarantee that only ammonia evaporates. There is also going to be like water with it, so that's like a extra suck in that instance. In here we will only burn sulfur, and the only water vapor is going to come from the atmosphere, basically from the air that we need to desiccant, so it is going to be more effective, and also going to take longer to fully wet the material and to reduce our yields, because if you have and allow the water from the so water, aka the moisture from the atmosphere, to get to the catalyst bed, that's going to reduce the yield and also going to fuck up the temperature and the reaction kinetics there. So yeah, I think that's it for now. Yeah, nothing to say. So thanks for watching. If you enjoyed, yeah, make sure that you like and subscribe, all that bullshit. Comment down below, spam the comments, so it helps the algorithm. I know it's cringe to us, but you know, get the point. Thanks for watching. Do the hard work, especially when you don't feel like it. Mwah.